Hi, my name is Nicole. Today I'm looking at the yield to maturity on an outstanding bond that I have with WeCare Home Health. The bond has a par value of $1,000 and has a coupon rate of 6.25% that's paid semi-annually. The bond has a current market price of $1,118.31, and it has 10 years until it will reach maturity. Based on this information, I want to find out what the annual yield to maturity will be on the bond, and I'm going to think about this problem using Excel. I'm going to begin by putting down all of the information that I already know in my Excel file. I know that the current price of the bond is $1,118.31. I'm going to put this as a negative value because this would be money that would have to go out of my pocket in order to buy the bond. I also know that the par value of the bond is $1,000, and I'm going to put this as a positive value because this is money that I would be getting back. It would be a cash inflow for me once the bond has matured. I'm also told that the coupon rate is 6.25%. Now this is an annual rate, and I'm told that the bond pays coupons semi-annually. So in order to find out what the semi-annual coupon rate is, I'm going to take the annual coupon rate and divide it by 2, and that gives me the semi-annual coupon rate. I'm also told that there will be 10 years until this bond reaches maturity. But again, since we're dealing with a bond that has coupons that are paid semi-annually, I'm going to take the number of years to maturity and multiply that by 2, and that will give me the number of semi-annual payments. Based on this, I can also calculate what the coupon payment will be. The semi-annual coupon payment will be equal to the semi-annual coupon rate multiplied by the par value. So all in all, this bond is worth $1,118.31 now that I would have to pay out to buy a bond. The bond would pay $31.25 in coupons every 6 months because it's a semi-annual coupon payment. And the par value is $1,000. That's the amount that I would get back at the end of this bond's life once it reaches maturity. One way to go about this problem is to do somewhat of a timeline in Excel. I'm going to put the period number here. I'm putting period number instead of year because there will be 2 payment periods per year. So I will be going from 0, which is today, and then number 1 would be after 6 months, period 2 would be after a year, and so on. And since I've established that there would be 20 semi-annual payments, I'm going to go all the way up to 20. I also know the bond value. The bond value right now is $1,118.31, and again that's negative because it would be a cash outflow. Then after one period I would get a coupon payment of $31.25, and that coupon payment would continue throughout the life of the bond. These are the coupon payments. I know at the end of 20 periods the bond would sell at par for $1,000. And then I can take the total value of the bond, and that's just the sum of any payment that I'm making to buy the bond or payment that I'm getting back from the bond, plus the coupon payment in that period. So I can see that today if I were to buy the bond, it would be $1,118.31 going out of my pocket. There'd be no coupon payment in that first period, so the total value is just equal to the amount I would pay for the bond. Then after 6 months, I would get $31.25 just in coupon payment. Then I can see that at the end of the bond's life, once it reaches maturity, I would get the $1,000 mature bond back plus the coupon payment for that period. If I look at all of these cash flows throughout period 0 to 20, I can use the IRR function, it's the internal rate of return function, in order to calculate what the yield to maturity would be. And then for the IRR function, I would just select all of the cash flows. And so I get a rate of 2.38%. This is the semi-annual rate of return. In order to get the annual rate, I would need to multiply that semi-annual rate by 2. And so that rate is 4.75%. I can also calculate it without doing all of these cash flows and without kind of doing the timeline on Excel. I can do that by using the rate function. And so then I put in the number of periods, which here is 20, because I'm going to have 20 semi-annual periods until this bond reaches maturity. The payment amounts are the coupon payments that I receive in each period. So that would be $31.25 here. That was calculated by using the semi-annual coupon rate and multiplying it by the par value. The present value of the bond is negative $1,118.31. That's the amount of money that I would have to pay to buy this bond right now. And the future value of the bond is $1,000. That's the par value, the value of the bond once it reaches maturity. And again, I get a value of 2.38%. Again, this is the semi-annual rate because we use the semi-annual coupon rate and the number of semi-annual payments. In order to get the annual rate, I would have to take the semi-annual rate and multiply it by 2. And again, I get that 4.75% as the annual rate, and that is the bond's yield to maturity.